My name is Alan. That's the second time I present it because the first time it crashed, the computer restarted. But let's see if we can do it now. Kangaroo, how to say the Kambari, Kambari, very hard here. So I will present about my project where I create a head-up display for motorcycles or motorbike helmet using NuttX. And so this project is not for only motorcycle, so we can use it for any vehicle or any export that requires helmet, even for astronaut from NASA or SpaceX, it could be useful. So if someone from there are listeners, let's to implement this idea someday. So let's move on. First, what is the head-up display and the history about it? So I will present the history and how it was developed over the years, why to create a head-up display for motorbikes, how I came up with this idea, an overview about the architecture of this project, how things are interconnected, implementation and issues and challenges that I faced during the development, and the testing and demo here. So, and also the improvement for future versions. Okay, from Wikipedia, what is the head-up display? Basically, a head-up display is any transparent display that presents some data without requiring users to look away from their usual viewpoint. So, as you can see here in the screen, this is what normally some airplanes, aircraft, and some helmet of the fight jetters use to get information without looking to other place. Because, for example, imagine you are in the fight in a fight jet, and you need to look down to get some information. So this is enough time to get some hit or crash with other aircraft. The first head-up display patent is from 1937, so it's almost 100 years already. So it's already old technology, let's put this way, but it's still new. And for this original idea, as you can see here in this diagram, it was like a teleprompter. You know, in TV, the teleprompter idea, you have some semi-transparent mirror, and it reflects back the image from the back, and you can see the image in front of you with this information overload or overwrite over that. So a history about the overhead display continuing, for example, during the following years. Initially, that application was more used for like some guns main target point. So you see exactly where you're going to shoot. So the initial purpose of the technology was not for only get information about the speed or something like that as we have today. It evolved around the years. So initially in the Royal Air Force in the England, after that Royal Navy, and it evolved a lot after the 75 with this Klopstein company. They became very famous manufacturer of head-up display for aircraft and commercial airplane. And currently, most commercial passenger aircrafts use head-up display. So why to create a head-up display for motorcycles or motorbikes? First, because it improves security. For example, imagine you put your smartphone in the motorcycle dashboard. Every time you need to look back, you are remove your focus from the street. So it's not ideal. And using the head-up display, you can improve this this issue. You can avoid looking down and just focus in the street. Also because it is convenient and easy to use. So, for example, you don't need to have to express your head looking up and down all the time, your neck. And also the most important, because it's a really fun project. So I enjoy doing this project. And to be honest, I think it was one of the most funny project that I have developed over the years. And how I get this idea, how I realized it could be nice to create some head-up display. Some years ago, I was using the Google Maps, and when I hit the home button, I realized it's create a picture-in-picture image. This white square in the here in the screen. And then I realized, oh, if I have some small OLED display, transparent OLED display, I could draw this image on that display. But at the time, I didn't find any transparent OLED display. And some two or three years ago, I saw they release low-cost OLED display that is very easy to find on AliExpress and many other robust sites. As you can see here, it's running on NuttX, and it is completely transparent, not completely, but 80 or more % transparent, so you can see the background and still seeing the image drawn on that. This is my idea of the architecture for the project. In the left side, we have your smartphone. That Google Map picture-in-picture is in the corner, in the top left side, and it is running the VNC server. Why to use VNC server instead of create an Android application? First, because I don't need to create the application myself. is a good advantage. The other advantage is, imagine if I create it for Android, and for some reason I decide, oh, Android is not good anymore, I want to use iPhone. I hope it never will happen in real life, but let's suppose it happened. So I need to recreate the same application to iOS as well. So it's not good. And using VNC server, I can do it for any device, any smartphone that has VNC server, or even computer or anything else. So VNC server simplify the project. And in the right side, we have NuttX board. Actually, it can run in any NuttX supported board. We can use it with Wi-Fi, Ethernet, USB RNDs to connect with the board. In my project here, I am using USB RNDs, and it works well. although I think using Ethernet or Wi-Fi, it will be faster because this board is only USB full speed. It's not USB 2.0, not high speed. So the NuttX application will communicate with the VNC server. So I create a VNC client, and it will request this picture-in-picture area, and it converts the image, and it draw it into display. So before implementing the application, I decided to do some tests using VNC client and use the GIMP to do the edge detection algorithm. So as you can see here, the original image is a color image, and then I use the Sobel edge detection. Sobel is very used for image recognition algorithm because it is simple to implement, and it is fast compared to other more advanced algorithm. And then after the Sobel image was created, I converted to black and white. But there's some catch, there's some issues here. For example, if you do the Sobel conversion directly to black and white, you will miss some information. Some lines, for example, will disappear, or things bad will happen. So first, I sharpen. I increase the visibility of the line, so the colors become more sharp and more visible, and then I convert it to black and white. As you can see, all the information now are present in the final black and white image. And why black and white? Because that OLED display that I was using is only one color. It's only like green or blue in that case. So this way, I can only send one bit pixel. I can only have it on or off. My first attempt was use some existing VNC client, and I found this VNC view. It's a VNC client for Windows CE, and it is available in GitHub. But after I get it working, I ported from Windows CE to NuttX. And it was very easy to port because it was implemented in C, and because all the socket APIs are POSIX, so it's easy to convert. The only function that I didn't know is a Win32 function, and I used the ChatGPT to convert it for me and ask how to do that, and it helped me. But after I get it working, I realized it was not a good idea because the code quality of this. I hope this guy Wolfgang is not listening this presentation, but I found a better alternative. I create one from scratch. Oh. And what I did, basically, I got the VNC server that exists on NuttX and just did the opposite. For example, if the server receives some message, I know what the message I need to receive, so my VNC client just sent that kind of message. So it was mostly simple thing to do. It was, I don't say it's very, very easy, but it was easy to do. And the things was wrong was mostly my mistakes, and I will show about it just now. The first issue, as you can see here, in the first frame, I got all the information correctly, the X, Y, W, and H information correctly. But in the second frame, it starts to drift. As you can see, all the information are completely strange. For example, the position is an invalid value that doesn't exist in the display, for example. And I just realized that after requesting the frame and get the rectangle area, I was passing the area, the amount of the bytes I want to read, and also the size of the structure. But since I received the first data of the structure, I don't need to pass the structure size again. So I just remove that part that is not required. And here I have the weight and width and weight size multiplied by 4, because the Android image is 32 bits. So it's green, yellow, green, blue, and red, and transparent, the alpha. Yeah, exactly. And so I multiply by 4 because we have 4 bytes for each pixel. The second issue was because first I implemented this VNC viewer on Linux. I got the VNC 7 from NuttX, compiled it on Linux, and it compiled out of the box. I didn't did many modifications on that. It was mostly worked directly on Linux. And then I start to create the VNC viewer, implementing the things that were supposed to be implemented. But I didn't pay attention about the memory, because when you are in the Linux, you have all the machine memory. So who cares about the memory now? But after converting it, after compiling it on NuttX, I realized the CNC buffer was already big, because I was reading 128 by 128 by 4. And I was converting it for RGB 888A to RGB 888. So I was converting for 4 bytes to 3 bytes for each pixel. And this other buffer for receive these 3 bytes to remove the alpha, the transparent color, was already 49 kilobytes. And also I need another 49 kilobytes to save the edge detection image. So at the end, I was using too much memory because I was doing many conversions, and each conversion required more memory. So the first idea was just use the same RGB alpha buffer to convert it to RGB. So I just need to move the red to the alpha position, and then the green to the position was red was before, and then the blue to the green, and so on. And this way, I don't need to use more 44 kilobytes of buffer. And my next idea was also to convert the Sobel pixel to use only 4 colors, because as you saw in the previous image, it was only using 4 colors actually. So I don't need to to have 32 bits to save all the colors. But I don't need that because after I removed the RGB buffer, it was already enough to compile on the STM32F4 Discover board. So I decided to not to do the nest optimization. So as you know, too early optimization is the root of all evil. So let's keep this way for now. And this is what I see inside the helmet. As you can see, there is it's not so easy to see here in the screen, but it has the arrow that's shown in the Google Maps, and you can see the street. And also it's running here, and we have also some recorded video.
I can show the demo from here because I have access meeting. So
okay, if you want to play it, maybe yeah. Thomas, microphone. Yeah, one more slide.
No, I just turned on the microphone.
Okay. Okay. As Alison is showing here, we have the image in the Google, in the Android phone, and also display in the transparent OLED display, as you can see. It's only about 1 or 2 frames per second, but it's enough for using the helmet. And my idea is also to port it, for example, to ESP32 board. This way I can use Wi-Fi, and also I have faster processor, and it will be enough to get more frames per second. Okay, thank you, Alison. And now I need to return to my presentation. Okay, it's already okay, Tomek. Did you open the mic? Okay. So some future improvements. For example, my next idea is to use a bigger resolution transparent OLED display. For example, 128 by 128. I forgot to comment. This small device, this small display, is only 128 by 64 pixels. So I only see the like the middle of the picture-in-picture image. I cannot display the entire image, but even the middle is enough to get the idea about the map. So, for example, now we can see some flexible OLED display coming into the market. So, use some flexible, some plastic OLED display is better than using glass display. And it can shape or can adapt easily to the helmet visor, and it is better to use. So although initially I avoid create the Android or iOS application, but I think it could be easier because I don't need to do all these edge detection algorithm and so on in the board. I can do everything in the Android phone and just send the converted data. And that's it. So I hope you guys have enjoyed this project. And now we can, if you guys can come here and see it directly in the running in the board. And that's it. Thank you, Tomek.
Thank you, Alan. A really nice implementation of NuttX in a community project for a heads-up display. I bet that this kind of ideas have been used in the past and they will be used in the future by many companies.
Yeah.
I can see a really nice usability for skiing, because when you ski, you would want to see where you go.
Mhm.
And especially if you're off-piste skiing, so there are no flags, no nothing.
Yeah.
So good luck with your idea, and hopefully we will see it in a product in the market.
Yeah, I hope so. And the other idea is to contribute the VNC viewer to mainline, because for example, currently we have only VNC server, and sometimes you are running in a board that has a good display and you want to show some image from a computer. And also, other idea is to implement it like a VNC camera. So if you want to do some image recognition and you don't have some camera, you can just uh, export the image as a camera. So your application will open like /dev/vnc can 0, and we'll get the camera that have some pixels coming from a computer or from remote real camera, for example. Yeah, that's it.
Thank you. Do we have questions in the room or online?
I will
I
have
can
one
see.
question or several questions. Very nice project. Congratulations, Alan. I was,
Thank you.
working on thinking about something like this several years back, but there were no translucent displays yet. I saw one prototype in 2017. There was some company from Japan. The display is working, but the guy didn't even yet know, how much would it cost and what would be the availability. But then,
Mhm.
I asked Google to create this kind of layer in their application, and they added to the this Google Maps navigation special function for head-up display. So maybe aside of the VNC, it would be possible to access some special API in the Android just to get, the special display for the head-up display. So it's already there in Google Maps navigation. That would maybe make things easier, faster. So what display did you use, and how much does it cost?
This is SSD 1309. As I told, it's very low cost. So
Mhm.
it cost, I think, 10 or 15 US dollars. So it's not expensive, and that's the main advantage of this solution, because it's really low cost. And for example, you can create some product with that, and it will cost uh, few US dollars, probably less than 100 US dollars for sure. And yeah, this OLED display is used by many Arduino makers, so it's very accessible, very easy to find in uh, any hobbyist or online shopping.
Very
Yeah.
cool. Another problem I noticed, it would be kind of when it's gonna be a product, then you need to fit it with the MCU board and, then mount it in a helmet in some standardized way. For example, my helmet, I use pin lock on the, front shield, so I cannot really, attach it to the shield. And then there is a problem how to mount it, so it's safe in case of crash and so on to match other
Yeah,
helmets.
yeah. Uh, the ideal, the best solution for that, the ideal solution, is mounting this thing directly in the visor, in the um, like in the side of the helmet, where it's turned, and like there is the spinning uh, um, it's, it's spin notch that you can move up and down. So that area could be used for that. And so, for example, you can keep some USB charge on that, and before you go, you put your helmet to charge a little bit to charge the battery, and you will last for 1 or 2 days, for example.
Yeah, or you could put some, energy harvesting like wind or something outside the helmet and just, charge it with the speed of riding.
Yeah, yeah, that's
Congratulations.
also a good idea.
We have a display which will use some energy, so I don't think
Yeah.
that it will work on harvested energy. Anyway, I found on Google there are some interesting waveguides displays.
Yeah.
A bit more expensive, but
Yeah.
maybe worth.
Actually, I forgot to comment and to include here. There's a nice YouTube video about it. It's called 1 billion, $1 billion idea, and the guy talk about not about only about the read-up display, but all the technology existing today for display image in front of your face, because because the Apple Vision Pro, many companies now are also interested on that, and that kind of technology exists for a very, very long time, but only after some big companies start to make a dent on that, all the other small fish go after this whale. So that's the conclusion why there's so many people interested in that. And I try to find it. Maybe we can I can find it in my cell phone, please, and I'll share it here. So
Maybe an idea would be to share it on Discord.
yeah,
And continue with the
yeah,
conference.
I can share it with Thomas later if he's interested. And I think that's it. Okay. Thank you.
Thank you very much.
Thank you.